Section 8.4, the determinant of a square matrix. So we looked at determinants a little in the last section for 2x2 inverses. A determinant is a real number. It's primarily used in determining whether a matrix has an inverse. And then there are some other uses we're going to look at in the next section. We see here a coefficient matrix, column A, column B. The determinant uses those absolute value bars. That means you're taking the determinant of a matrix. And the formula we use, you saw this last section, is that AD minus BC. So A sub 1 times B sub 2 minus B sub 1 times A sub 2. So you get that formula. That's how you find the determinant of a 2x2 matrix. And that number in and of itself, not very important, but it's used in many different applications. So for example, finding the determinant of matrix A. So using those absolute value bars to denote a determinant. 2 times 2 minus negative 3 times 1. So 4 minus negative 3 or 7. Okay, so go ahead and take a look at the other examples. And now, minors and cofactors. This is how we find determinants of larger square matrices, larger than 2x2. It's a little more of an involved process. So kind of stick with me, okay? So a determinant is found by multiplying every entry by its cofactor. To get a cofactor, you have to find the corresponding minor first. So the minor is kind of a stepping stone. Now, every entry has a position. The subscripts, the row and the column. So 1, 1, 1, 2, 1, 3, so on. If you added those numbers together, you get either an odd number or an even number. Now this is kind of confusing language, but positions have negative signs. Now that doesn't mean the number is negative, but whatever the number is, you put a negative on it. It has a negative sign attached to whatever it is. Even positions have positive signs. So whatever it is, you attach a positive to it. Now that won't change it, so it is what it is. Odd positions aren't necessarily negative, but they have a negative sign attached to whatever it is. Okay? Now to find minors and cofactors. Kind of an involved process, okay? So the minor of position 1, 1, the first row and the first column. To do that, you're going to go to a matrix, you're going to eliminate the first row and the first column. You're left with a resulting square matrix. You find the determinant of that matrix. Here we have a 2x2. So you can do the AD minus BC. So negative 1 times 1 minus 2 times 0. and you end up with -2. So that is your minor value. The cofactor of that minor value. Okay? I'm sorry. Whoa. Before I get too far ahead of myself, I should go back to school. -1 times 1, -1, not -2. Now the cofactor of that minor. The position is first row, first column, so 1, 1. 1 plus 1 is 2. You attach a positive sign to that, so a positive sign of -1. It's going to still be -1. Alright, so the minor, then the cofactor. Now let's do that again for the first row, second column, okay? So go up to your matrix A, the first row, eliminate that, the second column, eliminate that. You're left with the resulting square matrix, 3, 2, 4, 1. That did 2 by 2, so you find the determinant of that. 2 by 2 has a very simple formula. Cross multiply, not really cross multiply, but kind of cross multiplication. 3 times 1 minus 2 times 4. So that's 3 minus 8, 3 minus 8, -5. So that's your minor right there. To find the cofactor, look at the position. So first row, second column. 1 plus 2 is 3. 3 is an odd number. So whatever your minor is, attach a negative to that. So -5. So that becomes +5. That's your cofactor for not 1, 1, 1, 2. Now let's do this again for the third column, first row. So minor 1, 3. So go to matrix, first row, third column, eliminate those, you're left with a square matrix, which you find the determinant of. So 3 times 0 minus -1 times 4. 0 minus -4 is 4. So the minor of 1, 3 is 4. To find the cofactor of 1 by 3, look at the position. 1 and plus 3 is even. So you attach a positive to that 4. So your cofactor is 4. So over here, erase this. Now let's go to the second row. So the minor of 2, 1. Go to matrix, second row, first column. The resulting square matrix you have left over, find the determinant of that. It's a 2 by 2. So AD minus BC. And 2 minus 0 is 2. So that's the minor. To find the cofactor of 2, 1. 2 plus 1 is 3. 3 is odd. So the minor has a negative attached to it. So the 2 becomes -2. So go ahead and pause the video, find the rest of the minors and cofactors. When you've done that, start the video up again. Now, to find the determinant of a square matrix greater than 2 by 2, you have to use minors cofactors. What you do is, you take an entry, whatever that number is. Go ahead and get them all now. So that entry, and every entry you multiply by its corresponding cofactor. So again, the minor is a stepping stone to the cofactor. So an entry times its cofactor. Now the nice thing is you do this for any one row or any one column. You don't have to do it for all of them. You choose one. A row or a column with a lot of zeros is preferential because the zero entry times the cofactor cancels it out. So choose the row or column with the most zeros in it to make the problem simpler. Now we can see that this formula works if we try it for a 2 by 2. So the determinant of A is the entry in the first row of first column times the cofactor in the first row of first column. Add the entry in the first row of second column times the cofactor of the first row second column. So our first row first column entry, A sub 1. Our cofactor for the first row first column, can eliminate first row first column, B sub 2, that's an even position. And now our A sub 1, 2, our first row second column entry, B sub 1, eliminate the row column. Your resulting matrix is A sub 2, and 1, 2 is an odd position, so that A sub 2 is negative. So we have A sub 1, B sub 2, minus B sub 1, A sub 2. So we have that AD minus BC. So we're going to see this formula works for a 2 by 2. Therefore, it will work for a 3 by 3, 4 by 4, etc. So when you do this, choose a row or column that has the most zeros in it. I'll choose the first row that has a 0 in it. Why not? You could choose any row or column. You'll get the same answer as me. So there's multiple ways to get the same right answer. So the determinant of matrix A is 0 times the cofactor of 1, 1 plus 2 times the cofactor of 1, 2 plus 1 times the cofactor of 1, 3. Now the 0 cancels out quite conveniently, that's nice. To find the cofactors, let's go about that. So the 2, first row, second column, eliminate the row and column. The minor for 1, 2 is going to be 3 times 1 minus 2 times 4. So 3 minus 8, negative 5. 1, 2 is an odd position, so attach a negative to the negative 5, so a negative 5. Gonna be 5. Alright. Do that process again for first row, third column. So eliminate the row, eliminate the column. So the minor of 1, 3. 3 times 0 minus negative 1 times 4. So 0 minus negative 4, that's 4. Our cofactor, 1 plus 3 is 4. That's an even position, so attach a positive to the 4. So it remains 4. So now to find the determinant, we have 2 times its cofactor, which is 5, plus 1 times its cofactor, which is 4. So we end up with 14. If you did any row, any column, you'd always get 14, okay? So take a look at the remaining examples. Check your work with my complete notes online.